Assalamualaikum and good day to our lecturer and fellow viewers. We are students from the Bachelor of Engineering Hons Mechanical EM 220 program. Today we are presenting our industrial visit finding for the course MEC 640 or OSH and Manufacturing Technology. Before we begin, let me introduce our team. First is Muhammad Shazwan, Aiman Jufri, Amir Faris, Nazul Rafi, Ahmad Zahid, and me, myself, Hafizul Anas. On this slide, we can see several photos taken during our visit to the factory. This image captures our group observing the real world manufacturing operations and the industrial environment at the plant. It was a great opportunity for us to see the theories we learned in the class being applied in a large-scale production setting. So, introduction. The company we visit is Malaysian Die Casting Industries Berhad or MDI. Established in 1980, MDI has over 40 years of expertise in the industry. They are specialized in precision aluminium die casting and machining, serving as a trusted supplier to global customers. Their mission is focused on delivering high-quality components while continuously improving their processes and upholding strict safety and environment standards. Moving on the core of their operation, the manufacturing process. It begins with tooling design and development, where MDI fabricates molds strictly according to products, specification and quality. The primary process is aluminium die casting. They utilize high pressure to form precise and complex components. Key technical elements involved in this stage including the molding, sleeve, and runner system. Once the casting is complete, the parts undergo CNC machining to achieve accurate dimensions and tight tolerance. They utilize advanced machinery like the Brother DC2S2D0 for high precision milling and drilling. To ensure the final product is flawless, secondary processes are applied. These include deburring to remove sharp edges, taping, and a doubling process for the final finish. And finally, every product must pass through quality inspection and testing. This step ensures that every component meets both the specific requirement of the customer and international quality standards.
Assalamualaikum, my name is Ahmad Zahid. Now we will look at specific safety techniques implemented within the production area. Our strategy begins with three fundamental pillars of protection. First is personal protective equipment or PPE. There is a strict requirement for a full PPE for anyone entering the production section, especially for those who are in charge of machining and tools. This ensures a baseline of personal safety against common industrial risks. Second, we focus on machine safety and guards. Every machine in the production section is equipped with a systematic machining guard to prevent accidental contacts with moving parts. Third is chemical and material handling safety. To minimize manual handling risks, they use machines for systematic material transport. Furthermore, they prioritize sustainability by ensuring raw materials are handled properly and that waste material are reused for future products whenever possible. For the second half of our safety framework focuses on operational oversight and standardized procedures. Our fourth technique involves with standard operating procedures, which is SOP. You will find SOP reminders posted at every section and machine area. These are not just text-heavy documents, they utilize clear diagrams to explain procedures, making them easy for operators to follow at a glance. Fifth is hazard identification and risk assessment, or HIRAC. Each machine on the production site has undergone a specific hazard identification process to identify potential failure before they lead to an accident. Finally, we maintain regular safety inspection and audits. This includes a scheduled annual inspection for all tools to ensure that they remain in good condition. Additionally, a dedicated safety officer is on duty during every working hours to observe worker safety and uphold their culture, safety first culture.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Jufri bin Azli. So I will be presenting on the topic technology employed in die casting in Malaysia. So this presentation explains the main technology used in modern die casting industry to produce high quality metal components efficiently and safely. So first we have high pressure die casting (HPDC) technology. In this process, molten metal is injected into a mold under very high pressure. This allows the metal to fill complex shapes with high accuracy and smooth surface finish. HPDC is widely used in Malaysia because it is suitable for mass production and produce consistent, high quality components for industries such as automotive, electronic and machinery. So for the next one, next is advanced die casting machines. Modern factories use automated die casting machines that operate with a controlled parameter such as pressure, temperature and timing. This machine improve production speed, reduce human error and ensure uniform product quality, which is very important for industrial manufacturing standards. So for the third one is automated robotic system. Robotic arms are used to remove cast parts from the mold and transfer them to the next process. This increases production efficiency and also improve worker safety by reducing exposure to high temperatures and heavy machinery. So moving on, we have precision mold and tooling. The molds are produced using high precision CNC machining. This ensures tight tolerance, accurate dimension and smooth surface finish. High quality molds are essential to produce components that meet design and engineering requirements. So number 5 is quality control technology. Inspection tools such as visual inspection system and dimensional measuring instrument are used to check product accuracy and quality. This ensures that every product meets customer specification and industry standard. And finally, secondary and finishing processes are carried out. These include trimming, deburring, and surface finishing processes. These steps improve the final appearance, accuracy, and functionality of the component before they are delivered to the customer. So, in conclusion, we can say the die casting industry in Malaysia use advanced technologies such as HPDC, automation, robotic, precision tooling, quality control system and finishing processes to produce high quality product efficiently. This technology support industrial growth and strengthen nation's manufacturing sector. And that's all for me. Thank you.
First of all, my name is Nazrul Rafiq bin Rohaisan and I will explain about our design concept that we gained from our site visit. First, the part design focuses on design for manufacturability, meaning components are easy to cast and suitable for mass production while reducing defects and costs. Next, we emphasize dimensional accuracy, where tight tolerance are maintained to reduce the need for excessive secondary machining. We also consider surface finish, ensuring good surface quality to minimize post-processing and improve the final appearance of the product. In terms of mold design efficiency, proper gating and runner system are used to ensure smooth metal flow and complete cavity filling. Finally, the design applies lightweight and strength optimization, where the structure is made lighter without compromising strength, making it suitable for automotive and industrial application. Next, this slide describes our quality assurance process. The process begins with incoming material inspection, where raw materials are checked to ensure they meet required specifications. During production, process monitoring is carried out by controlling critical parameters such as temperature, pressure, and injection speed. Next, in-process inspection is performed through visual and dimensional checks to detect defects at an early stage. After production, final product inspection ensure that finished components comply with customer and industry standards. Lastly, defect control and continuous improvement are implemented by analyzing defects and applying corrective actions to continuously improve product quality. That's all from me, and I will pass the next presentation to my friend.
Thank you, and I am Shazwan bin Sharudin. Now that we have covered the manufacturing process, I'd like to shift our focus to actual output of MDI's operations and the specific challenge they face on the production floor. Okay, first let's start with product produced. During our visit, we observed that MDI specialized in two main categories of components. First, they produce housings for electronic and mechanical parts. These are the protective shells you see on complex machinery. Second, they manufacture structural supports which are critical for holding industrial assemblies together. All of these parts are using aluminum alloy. So we ask ourselves, why aluminum? The answer lies in the engineering value. It allows MDI to create parts that are lightweight yet strong enough for industrial use. But MDI isn't just about making parts. Their competitive advantage came from three specific qualities. As we noted, first, high dimensional accuracy. They achieve tight tolerance, essential for assembly. Second, smooth surface finish. Through secondary tumbling and finishing, the parts are aesthetically and functioning smooth. Lastly, consistency. They maintain this high quality even during mass production. However, maintaining that level of quality in a die casting environment is difficult. This brings me to the challenge observed. We identify challenge in two main areas, which is category 01, technical quality, and category 02 for occupational safety. On the technical side, the biggest enemy is die wear and thermal fatigue, because the molds are subject to extreme heating and cooling cycles. They can degrade over time, leading to surface defects. So, MDI combats this by implementing controlled preheating and cooling of dies and optimizing the cooling channel design. They also strictly follow a maintenance schedule to ensure the mold lasts longer. On the safety side, the challenge is the environment itself. It is a hot temperature workplace due to the furnace and holding pots. So, to protect the workers, MDI use automatic handling system. This keeps human operator at a safe distance from a molten metal. Additionally, instead of relying on manual checks, they use fully sensor machine to monitor the process parameter, ensuring safety and precision simultaneously. In conclusion, MDI effectively balance high precision output with the high safety protocols to overcome the inherent challenge of the industry. That concludes my section. I will now pass the presentation to my friend. Thank you.
So for my part, I will present about emergency response and safety facilities. During our site visit to Malaysian Die Casting Industries, which is MDI, we observed that the company has implemented effective emergency response system and safety facilities to protect employees in high-risk working environment. MDIs also operate in both molten aluminium, high temperatures, heavy machinery and automated system, which make emergency preparedness very important. The factory is equipped with fire extinguisher, fire alarm system, and clearly marked emergency exit placed at strategic location. Emergency evacuation routes are clearly labeled to ensure workers can evacuate safely during emergency. In addition, first aid facilities and emergency medical support are available to handle injuries quickly. Workers also are provided with safety training and emergency drills, which help improve their response during accidents or unexpected situations. MDI also use robotic automation to reduce direct human involvement in dangerous processes such as molten metal handling and heavy lifting, which significantly lowers the risk of serious injuries. So for the discussion part, from the site visit, which is my team, we gain a better understanding of how occupational safety and health, which is OSH, is implemented in actual industry workplace. We also observe that MDI applies a combination of engineering control, safety procedure, and employee training to manage workplace hazards. The use of automation clearly shows how technology can help reduce risk in hazardous environment. This visit also highlights that safety is a shared responsibility between management and worker. Management provide proper safety facilities and systems, while worker must follow the safety rules and use PPE correctly. Overall, the visit helped us connect OSH theory learned in class to the real experience industrial practice and increase our awareness of workplace safety. So, last part, which is conclusion. The industrial site visit to Malaysian Die Casting Industry, which is MDI, provided valuable exposure to the real-world safety practice. In high-risk industry, we also learned how proper emergency response planning, safety facilities, and automation play an important role in preventing accidents and protecting workers. This site visit enhanced our understanding of workplace hazard, OSH implementation, and the importance of maintaining a strong safety culture. The knowledge gained from this visit will be useful for us because in our future careers, it will help us becoming more safety conscious and responsible professional. That's all for our presentation slide.